117?
On 8.3.
Dude, okay.
I'm going to use, like, I'm pretty sure I'm asking for n, and use that formula that n equals z squared. But I'm confused because the formula that you, I don't know how to, like, it's asking for the error, but I'm just confused.
No, it's asking for it tells you they want to be within how much?
I think it's 95%?
No. So I want to be 95% confident to be within how much?
0.03.
There you go. That's my error.
Oh, okay. Okay, I get it now. That's all.
This only tells you the z-squared. The error's got to be how close you want to be. Within, that's why within is a key word. It doesn't always have to be the word within, but it's a dead giveaway if you see the word within. Within 7 feet, within 3%, that would be 0.03. Now the trick with this, and the question I thought you were going to ask, is they don't tell me what the free p hat and q hat are. But we did cover that. When you don't know, you have to guess they're both 50%, 0.5 each. That mathematically makes n the biggest it has to be to cover my ass for not knowing what the hell they actually are.
Okay, thank you.
So you notice how that thread goes through. If there's something I don't know, I get penalized somehow, which makes sense. It's basically how, classes work, for example, right? You guys doing all right? Yeah. How about them Celtics? That's pretty good. That's my team. There's. Anything else from homework stuff? Alright, so what we're going to focus on today is we're going to focus on closing the door in chapter 9. There's a few little details we still have to go over. I think I want to start with we've done tests about the average, right? Tests about the mean. And sometimes we have to use t-scores. And of course, we all know when we have to use t-scores. When do I have to use t-scores? Of the sample. I love it. Cool. What we haven't done yet is how do I test a hypothesis about a percentage? Like if I said, I feel that more than 60% of my students pass my final exam or something, right? So what's going to have to change is this. Now, remember, let me just remind you guys, what is this the formula for? Just to go back a little bit. I love it. So the confidence interval for the mean. And remember how we sort of changed things and we started at the beginning again, but we reformulated it. We came up with one that works for percentages. And what's going to really help us out here is this idea. So the z-score for sample means, we know what it is. We've been using it forever. I don't know why I keep looking for another color because I don't have it. I hate that. I must have left it in my last one. Too bad for you, John.
There's some on the top.
Oh, really?
Yeah.
Oh, there's another purple. Yeah.
No,
There's a pink one.
There's a pink one. Yeah, that's awesome. Ooh, look at that. Let's see if it works. I think that's like a graveyard for markers. That is fun as hell, man. That's some freaky shit. See if that one works. Oh my god. Okay. I see why you're right there. That one works pretty well. Okay, so I'm trying to make this connection. So the beautiful thing, thank God, all the steps are going to be the same. Thank God there's not more steps. There's still just 5 steps. And you're all like, oh, that's bad news to me, but it should be good news. They're all the same steps. The only difference, there's going to be 2 main differences. Let me see if you guys remember. In order to, so here's the z-score for this, right? And you almost worked. Oh, and the blues too. Let's see. Blue. Got somebody who does this all day. Okay. Alright, guys. So this should look familiar, right? So we have a z-score. We use the z-score formula in that step 4 on the hypothesis test to see how far away we actually got. Are you guys with me? Alright. What does... and what do we have to check here to make sure that I'm allowed to even use z-scores? Yeah, sample has to be greater than 30. Now, what did we have to check? One of you guys is going to work better. Alright. What did we have to check here? You guys remember, there were 2 things I had to check. To see if it was normal enough. I had to check something greater than 5 and something else bigger than 5.
P hat.
NP hat. NQ hat. And that was so that the histogram would be in the middle so there was room for it to go up and come back down. I don't know if you guys remember that day that I talked about that. This is really exactly the same step as this. That's what you do when you have percentages. That's what you have to show when you have means. Yes?
So you just have to make sure that P hat and Q hat is greater than 5?
No.
What is the...
N times P hat.
N times P hat.
That's the mean, right?
Okay.
That's the mean successes, and I need the mean failures to also be bigger than 5. So it's in the middle. It's not all slammed up against one or slammed up against the other one. It's got room to come up and room to come down. Okay. So that's one change. The other change is going to involve the z-score formula. I can't use this z-score because I got frickin' p hats and I don't have any sigmas. I don't have any x bars. So here's how this is going to work. So down here is the standard deviation, right? Yes? What acts like a standard deviation for this? What's in the same place as the standard deviation for this guy? This whole thing, right? That's the standard deviation for group of whatever. So this is the standard deviation for percentages. Let me let that sink in. Okay. Alright. So I don't know if you guys remember the crazy claim I made that the z-score formula never changes. It doesn't. It's always my data minus the middle divided by the spread. Always. So in this case, what did that hat mean? Who remembers what the hell that hat meant? Was it graduating? Is there a little tassel in the back? Was it sombrero? There's a difference between P and P hat. Same difference between mu and x bar. Same difference between sigma and s. That's a sample. It's got a little hat on it. Just like the X got a little bar on it. And poor little S dude gets no clothing or anything. So it's going to make a Hogwarts reference. So my data is going to be P hat. Up here, what was my data? Well, it was the sample mean that I calculated. I took a sample. My data is the sample mean. Because that's what I took. Once my data here is going to be P hat. I took a sample and I calculated P hat. And then I'm going to compare that to the population percentage. That's the one without a hat. So what do I do up here? Why does this make sense for a hypothesis test? For step 4, I want to know how far away did my sample get from some accepted middle. If I get really far away, well, how far away is far away enough? Whatever that z-score is, that defines where the rejection region starts, right? So the idea is, somebody thinks it's here, I get way the hell out there, more than likely it ain't here. That's the whole idea of a hypothesis test, what I just said. So here, I take a sample, I see P hat. There's going to be a P from a claim that somebody made. Like if I think more than 60% of my students pass my final, I take a sample and I get 62%. Well, it is more, but is it more enough? So for that enough, I got to calculate a z-score for that. I got to see how far away it got. So on the bottom, it's going to still be the spread. But what's the standard deviation now for us? It's going to be this thing. That's what the standard deviation is. How do I know it? Because that's exactly in the right place to be the standard deviation. This guy here. Notice that I don't have hats on them because they only use hats if I don't know the actual percentage. And when I do a hypothesis test, I assume that whatever the claim is, that's the real percentage. Well, let's do an example. Let's do an example. I really desperately want you to kind of understand, this will be my new Z-star formula for percentages. So, we leave that formula there. Say, yeah, let's do the same thing. I think more than 60% of my students pass my final. I look at 250 recent finals and see, what do you see, Jeff? I don't know, man. Yeah, 156 passed. So, is my claim correct? So, test the claim at alpha equal to 0.05. Okay. So what? I'm gonna let you guys write that down. So what is that going to relate to? This alpha. What's it also called? Not just little fish dude. What else is this called? Starts with an L. It's 3 words. Sounds like, no, yeah. Level of significance. The smaller this is, the more significant my results would be. The reason I want you to really remember that is I might say, in the book might say, a level of significance of 0.01 or something. It's the same thing as saying alpha equal to 0.01. Alpha is the level of significance. Okay. So the first step is going to be, what's my claim, so I can set up my hoe and my eye. So what is the claim that's being made?
60% of students pass the time.
No?
More than?
Yeah. Now be more mathematical about it. So in English, the claim is more than 60% of my students pass my time. Let's clean that up. Let's make it in math. What's mathish say?
Greater than 60.
What is? No, there's no means here.
The probability?
The percentage. The claim is the percentage is greater than 0.6. And I just tried to teach I was more honest than I wanted to be. Tried to teach my math A class about percentages. Some of them got it. But the percentages, of course, are something humans made up. We understand 11% better than we understand 0.11. But math needs a freaking number. 60% is 0.6. So one big mistake people make when they throw stuff in here is they use 60 and 40. Oh my God. No. You got to use the actual number. It's going to throw stuff off. So which one does that go in for?
High.
Why the high?
It's greater than.
Because it doesn't have a 11. Sweet. So it has to be greater than 0.6. So the hoe's got to be
Less than or equal.
yeah, the opposite. Less than or equal to 0.6. I like it. So if I feel at more than 60%, that must mean I'm fighting against the idea that at most 60%. So they're opposite stances. Opposite ideas. Take you away from the Lord. What's the next step? First step is what the hell am I talking about. The next step is, before I can do anything,
Z-score.
The Z-score and T-score.
I love it. The fantastic thing about this, I don't know if you picked up on this yet or not. How many confidence interval formulas were there that start with X bar? How many confidence intervals formulas with X bar, plus or minus? How many of them were there? 2. What? Yeah, X bar plus or minus Z, X bar plus or minus T. How many ones started with the hat? 1. And it only had a Z in it. Because with percentages, we create our own standard deviation. So we always have the correct standard deviation. So I either can use Z-scores or I can't do anything. You never use T-scores with percentages. And this is another note. There is no percentage formula with a T in it. So they don't go together. That's fantastic. So step B would be, can I use Z-scores or nothing? And I have to check these two things. So what's N? 250. What's P? It's written up on the board already. 0.6. So hopefully, of course, Q is 0.4 if P is 0.6. Some of this should feel familiar. It's what I said when we first started hypothesis test. It's a lot of old stuff just kind of reorganized. So what is 0.6 times 250? 150. So 0.4 times 250? 100. And they're both bigger than 5. Yes. Bigger than 5, check. What does that mean again? That they're both bigger than 5? It's normal enough, he gets. Follows a normal curve, is normal enough. It's the same thing as the greater than 34 mean problems. Like a Z-scores, check. How many tail tests is it going to be? 1 tail. Where's it going to be? Okay, that's a C. There you go. 1 tail up here, so alpha is 0.05. I'm using Z-scores. It's a 1-tail test. So what is that going to be? Yes. But what's this going to be? What's far enough away? What's that Z-score? 1.645. Again, if I'm you, I'm going to use that T-score chart. And there might be some people left over still that are like, you said Z's, man, but of course Z's are at the... And the top is set up, yeah, it's 1 tail, 0.05. 1 tail, 0.05. All the way down, I am. Do you guys see that? Can you guys verify that for yourself, that you can find it? Okay? Maybe then. So if Z star is what? How related to 1.645? When can I reject the hoe? If it's greater than. Exactly. Reject the hoe and also at the same time support the high. Okay. So I know as students, I mean, details are important. I take points off, all these little detailed things, I understand that. But when you're learning something, don't get lost in the weeds. It's always the same idea. That number is going to change based on how bad it is to make a certain kind of error. I can control that probability. We talked about that a little bit. This number is sort of like, if I'm trying to prove something so I pay less money, the people I'm trying to prove it to is probably going to make this like 0.01 or 0.005, make it hard for me to prove. because they want me to keep paying a lot of money, right? We talked about with the fire insurance kind of problem. So this step just sets up what would show evidence, and the next step is how much evidence do I see? Did I get far enough out or not far enough out? That's the heart of this test, is right there. So the very next thing I'm going to do is I'm going to calculate Z-star and see where it fell. So what do I know from the sample? What do we know? What do we know from the sample? How would I get P hat? How do I get P hat from the sample? What percentage do you see in your sample? In the sample up here? No, that's the claim. What sample did I take? Did I take a sample? Yes. How big was the sample? 250. And out of those 250, I saw there's my sample. So 156 out of 250. What is that? 0.624.
Yeah.
I'll let you guys verify that. Please let that be easy. You got to know that percentages are part divided by whole. P hat is always going to be, the part out of the whole from the people or things that I looked at. So I've got everything I need now, believe it or not, for my Z-star. My Z-star was P hat minus P divided by square root of PQ over N. What's the only thing with a hat on it in there is that very first one, right? Everything else is going to be based on this stuff. So it's going to be my data, 0.624. That's what we calculated from our sample. That always comes first. Minus what we saw from the claim. And then you just throw that stuff in for the spread on the bottom and see how far apart they really are. Square root of 0.6 times 0.4 divided by 250. Be really careful when you plug this in. Do it that way. See if we all get the same answer. What do you guys get there? Who?
-18.
You know it's going to be positive because that's bigger than that, right?
77459.
Yeah, so 0.77.
Yeah.
So you want the top in parentheses. You want, if you have the newer model, you don't even need the parentheses. You just make sure the square root fits over everything. If you have the older one that opens a parenthesis for you, don't close it because that means you came out of the square root symbol. So yes, garbage in, garbage out. Actually plugging things in the calculator correctly is important. It's funny, my Math 88 students desperately want to use a calculator, and when they get here, they're like, I don't know about that anymore. This thing is killing me, everything wrong. Well, you got to use it right. What is that? What is that? What the hell does that mean? That's right. Z star is 0.77. What does that measure? Don't tell me the number standard deviation about it. What does it measure here specifically? What's on the top?
No support the high since it's greater than
Well, see, where's 0.77 on this? Where's it at? 0.77. Here's 0, right? 0.77 is like right there. It's not even a full step away. Is that unusual looking back at the way we used to look at it? No. In fact, now we've defined this to mean unusual. We didn't meet that. We're right there. We're at 0.77. So yes, that sample mean was higher than, sample percentage was higher than 60%, but not high enough. It wasn't higher than that enough, because it's just a sample.
So we failed.
Totally, yeah, we failed. Did we make it into the rejection region? No, so therefore we failed. We did not find enough evidence. Failed to reject the hope and support the high. Which language am I going to use? What was my claim?
That the percentage was greater than.
Yeah, so the claim was the high, right? So I'm going to use this language. This is what drives me a little bit in saying this. People are just kind of guessing at which words to throw in there, but there's nothing to guess about. The claim was the high, so I used that language. So then the last step. Oh my gosh. We have not found sufficient evidence to support the claim that more than 60% of my students pass my finals. Yeah. Became a different language at the end, but well. Some of you guys are like, it started off as a different language. Okay. So just to point out, I know that you all love hypothesis tests. I know that's true. I know this is still relatively new, although we've done a lot of these. But what I really want you to notice is there was only two things that were different. This is related to n greater than 30. This is the check I got to do if it's percentages. And this. But of course, I'm going to have it sitting on my formula sheet. I'm going to use it when I have freaking percentages, because it's got percentages in it, right? So, on one side of this is the practice test. So please just look at that later. On the other side is what I want you to try to do right now is 2 examples of this kind of hypothesis test.